So we've seen that for any sort of system that oscillates according to simple harmonic motion, that the acceleration and the position have a definite relationship. They are proportional to each other, but it's a negative proportionality, meaning that if x points to the left, then a points to the right. We also have that same situation between force and x for a spring. And so what we're going to look at here is to sort of see how the ideas of a mass on a spring truly are simple harmonic, and learn how to use the characteristics of a spring, the spring itself, and also the mass of the object on the spring to help us determine how quickly the system oscillates. So if I start with the formula F equals negative kx, and I make just a simple substitution, F equals ma, and then just rearrange things a bit, we can see that the acceleration is in fact related to x in the way that we have talked about before. It has that negative times a constant times x relationship. And so by just sort of matching up parts, we can see that the value of omega squared must be equal to k over m. So this allows us to determine the frequency, the angular frequency, the period, and so forth by knowing the spring constant and the mass. When we look at our formula sheet, we actually won't see it in exactly the same way. It will look more like this. Okay, it talks about it in terms of the period, but I want you to see that this really does mean the exact same thing. If we include some of the information that we have learned and is on the formula sheet relating period and omega and regular frequency f, we are able to see that the two ways of thinking are really just the same. This is just substituting 2 pi over t in for omega, squaring that, and then just working through a little bit of algebra, cross multiplying, and then isolating the t squared. And we can see then that by taking the square root of this result, we do in fact get that period relationship. And this allows us then to think about a system, to notice that if the mass on a system is increased, that we would expect the system to move more slowly, meaning it would have a higher period. As m goes up, t goes up. And then also to notice that if we change the spring and we used a tighter coil to a spring, meaning a higher spring constant, that the period then would decrease and it would oscillate very quickly up and down.